GE Oil and Gas is a leading provider of specialized equipment and technologies for every stage of hydrocarbon production. From upstream drilling and subsea installations to midstream transportation and downstream production and refining, GE Oil and Gas delivers a high degree of system performance and on-site expertise. With service locations in every major oil and gas producing region, we stand behind the extensive catalog of products.
Hi, I'm Chuck Chauvier. I run the drilling business for GE Oil and Gas. You're about to see a video that shows some of the challenges in deepwater well construction. It'll show some of the products and technologies used to help provide the world a safe and reliable energy source. Please enjoy the video.
When a seabed drilling location has been identified, a string of drill pipe with a guide base, conductor pipe, and special jetting fixture on the end is lowered underwater to the well site. The initial wellbore is created by washing out the seabed using high water pressure forced through the drill pipe. As the hole is formed, the conductor pipe is inserted until the guide base is resting on the ocean floor. The conductor pipe prevents the hole from collapsing, and the guide base provides a foundation for the conductor. Once this equipment is installed, the next phase, installing casing and the wellhead, can commence. The drill string returns to the surface where a drill bit is installed. The drill string is lowered through the conductor pipe into the hole and used to extend the wellbore to a predetermined depth, which will permit the installation of the first length of casing. Upon reaching the target, the drill pipe is brought back to the surface where the bit is replaced with a casing running tool. The running tool is normally used to install the wellhead and the first length of casing into the wellbore. Like the conductor pipe, the casing preserves the integrity of the wellbore as the hole deepens. When this procedure is complete, the wellhead, conductor pipe, guide base, and casing create a single assembly. The casing running tool on the end of the drill pipe is replaced with a cementing tool, and the casing is cemented in place. The cementing operation increases the integrity of the wellbore and integrates the casing into the seabed formation. With the wellhead and initial string of casing in place, it is time to install the blowout prevention stack on the wellhead. The stack is positioned over the moon pool, and electric cables and hydraulic hoses are attached. When the stack is underwater, these umbilicals are used to control the stack from the surface. The first 90-foot section of riser, a large pipe which acts as the wellbore between the rig and the wellhead, is connected to the top of the stack using the spider. The GE spider and riser system is unique in that the design is intended to eliminate human contact with the riser. This feature is intended to save time for the customer and reduces the risk of injury to personnel when making up connections. With the first joint of riser connected, the stack is lowered into the sea. As additional joints of riser are attached, the stack is lowered into the water until it is just above the wellhead. Because water depths can reach up to 12,500 feet, this operation can take 1 or more days to complete. When the stack approaches the wellhead, the termination joint is installed on top of the riser. The termination joint is the surface connection point for hydraulic hoses, which supply fluid to the choke and kill lines and rigid conduits. The rigid conduits are smaller pipes on the outside of the riser which act as pathways for pressurized hydraulic fluid designed to control the stack. The choke and kill lines carry drilling mud used to help control the pressures in the wellbore. The telescopic joint, which includes a tension ring assembly, is installed above the termination joint. The installation of the upper flex joint and diverter completes the assembly of the riser string. On the surface, the telescopic joint is slowly extended. This action slowly lowers the stack onto the wellhead until the wellhead connector comes in contact with the conductor pipe. Using hydraulic pressure, the wellhead connector latches the stack to the wellhead, completing the path from the rig to the well. Finally, the tension ring pulls up on the riser to create a straight path between the ship and the well. This action helps prevent damage to the riser and the stack during drilling. The wellhead connector and all of the stack functions are controlled from the surface using the MUX control system, which receives electric power through a self-contained, dual-redundant power management system. From this system, power is distributed to several control stations which are located at various points throughout the rig. These stations communicate system data and command signals over two redundant networks. The control stations also communicate with the stack controls through dedicated cables connected to the stack. The stack uses pressurized hydraulic fluid to perform its operations. The fluid is stored in tanks on the rig, and a series of pumps pressurize it for delivery to the stack. This hydraulic pressure is stored in surface accumulators and routed to the stack through the rigid conduits on the riser and the hydraulic hoses attached to the stack. The stack is composed of two sections. The upper section is referred to as the Lower Marine Riser Package, or LMRP. The bottom section is referred to as the lower stack. The LMRP contains two control pods, which communicate with the surface control system, and two annular blowout preventers, which seal the wellbore. The lower stack contains multiple ram blowout preventers used to shear pipe and help seal the wellbore under various conditions. Pipe ram blocks are designed to close and seal around a specific size drill pipe. Variable pipe rams provide more versatility, as they can close and seal on a range of pipe sizes. Casing shears are designed to cut through large diameter pipes, but do not seal the wellbore. The blind shear ram blocks are designed to cut through the drill string or the tool joint where two sections of drill pipe are connected and seal the wellbore. The two sections of the stack are held together by a connector on the LMRP and a mandrel on the lower stack. This assembly is similar to the one that latches the stack to the wellhead. At this point, full-time drilling operations normally begin. A cutting bit is installed on the end of the drill pipe and lowered through the riser and the stack into the existing wellbore. As the bit reaches bottom, the driller applies rotation and downward force on the drill string to cut into the formation. To cool the bit, mud is pumped down the drill pipe and into the wellbore through nozzles in the bit. The mud also cleans out the wellbore, washing the cuttings back to the surface through the annulus, which is the space between the drill pipe and the wellbore. The weight of the mud prevents fluids and gas, which are under pressure inside the formation, from rising to the surface in an uncontrolled manner. As the drill bit travels deeper, it may penetrate a pocket of fluid or gas which is under a higher, unanticipated pressure. When the weight of the mud is not sufficient to hold the formation pressure in place, this is called a kick. When the drilling operator is alerted to a kick, the drill bit is raised off the bottom of the wellbore and drilling operations are stopped. The operator attempts to contain the rising pressure in the wellbore by sending a command to the BOP stack to close the annular blowout preventer. The annular is designed to seal around the drill pipe and prevent the excessive pressure from continuing up the riser to the rig. In cases where the drill pipe is not in the wellbore, the annular is also designed to seal an open hole. Under certain conditions, some of the pressure may pass through the BOP stack before the annular is closed. As this uncontrolled pressure travels up the riser, it increases in size and speed. In response to this condition, the diverter can be closed and the excess pressure routed away from the rig to help prevent injury to personnel and damage to equipment. In situations where remaining on location would be hazardous, other features of the stack provide options to help ensure the safety of the rig and crew. Rough seas, for example, can make it difficult for the rig to stay in position over a well. In these conditions, it may be impossible to safely continue drilling operations. If there is not sufficient time to pull the drill string out of the wellbore, the operator performs a disconnect sequence, which will detach the rig from its connection to the ocean floor. When this occurs, the control system is designed to close the pipe rams around the drill string to seal the wellbore and help prevent wellbore pressure from escaping. Then the drill string is lowered until the tool joint rests on top of the pipe ram block located below the shear rams. This can prevent the drill string from falling into the wellbore when the drill pipe is sheared. As the blind rams close, they shear the drill pipe and seal the wellbore in the lower BOP stack. At the surface, the tension ring is released to relax the riser. Then the control system issues the command to unlatch the connector between the LMRP and the lower stack. When the LMRP separates from the lower stack, the rig is free to move to another location. To save time, the LMRP is not brought back to the surface. After sea conditions return to normal, the rig can return to the drilling site and reconnect the LMRP connector to the lower stack. With the LMRP in place, communication with the lower stack is reestablished. Once the sheared drill pipe is repaired, drilling operations resume. In summary, the GE Oil and Gas drilling products are designed to help our customers drill wells safely in deep water applications. The casing, conductor pipe, guide base, and wellhead provide the foundation for the blowout prevention stack. The lower stack contains a series of ram blowout preventers. The LMRP connector holds the two sections of the stack together. The LMRP is equipped with annular blowout preventers and control pods. The riser allows fluid communication through the water between the stack and the rig. At the top of the riser, hydraulic hoses are connected to the termination joint. The tension ring keeps the riser straight, and the telescopic joint and the flex joint compensate for the movement of the rig on the sea. The diverter helps direct high pressure away from the rig at the surface. All this equipment is operated using hydraulic pressure, electric power, and network communications managed at various locations on the rig. Together, these products are designed to provide reliable methods of controlling pressure during drilling operations.
So you've just seen a video that shows many of the challenges and technologies used in the deepwater drilling space. Here at GE Oil and Gas, we're excited by challenges the industry faces. So if you're a customer of ours, an employee of ours, or you're considering joining a team like this that's excited to solve those challenges, we certainly ask you to reach out to our organization or to go to our website to find out more about our business. So thanks to each and every one of you for watching the video. Have a great and safe day.